Everything we see, touch, build, and observe in the universe is shaped by four fundamental forces. Force number 1 is gravity. Gravity holds planets and stars together. Force number 2 is electromagnetism. Electromagnetism gives us light, electricity, chemistry, and everyday contact forces. Force number 3 is the strong nuclear force. The strong nuclear force binds atomic nuclei. Force number 4 is the weak nuclear force. The weak nuclear force allows certain particles to change identity, and make some forms of radioactivity possible. In this video, we will meet these four forces, and see how each one plays a special role in nature. Gravity is the force that acts between masses. It is always attractive. This means masses pull one another together. Although gravity is the weakest of the four fundamental forces, it has an enormous influence. It acts over long distances, and cannot be cancelled out easily. Gravity keeps us on Earth, holds the Moon in orbit, and guides planets around the Sun. Gravity also helps form stars, galaxies, and the large-scale structure of the universe. Gravity may be the weakest force, but across space, it shapes the largest structures we can see. Electromagnetism acts between electric charges. Unlike gravity, it can attract or repel. Opposite charges attract, while like charges repel. This force is responsible for electricity, magnetism, light, chemical bonding, and the structure of atoms and molecules. Friction, tension, normal reaction, and the firmness of solid objects all come from electromagnetic interactions between atoms. Electromagnetism is the force behind much of the everyday world we see and feel. The strong nuclear force holds protons and neutrons together inside the atomic nucleus. This is remarkable, because protons are positively charged. They repel one another electromagnetically. The strong force overcomes that repulsion. But it works only over extremely short distances inside the nucleus. Without the strong nuclear force, stable atoms would not exist. The matter around us could not form in the way we know it. The strong nuclear force is the hidden binder of atomic matter. The weak nuclear force is not mainly about pushing or pulling objects in the everyday sense. Its special role is transformation. It allows certain particles to change into other particles. A key example is beta decay. In beta decay, a neutron can change into a proton, while emitting an electron and an antineutrino. The weak force is essential in nuclear reactions, radioactive decay, and processes inside stars. These include the chain of reactions that help the Sun produce energy. The weak nuclear force is the force of particle transformation. The four forces differ in strength, range, and function. Gravity acts on mass, and dominates at cosmic scales. Electromagnetism acts on electric charge. It shapes atoms, molecules, light, and technology. The strong nuclear force is extremely powerful. But it acts only inside atomic nuclei. The weak nuclear force has a very short range. It is best understood as a force of particle transformation. Together, the four forces explain both the visible world, and the hidden world inside matter. In real nature, the four forces are not isolated topics. They work together across different scales. The strong force holds nuclei together. The weak force enables nuclear transformations. Electromagnetism builds atoms, molecules, materials, and living chemistry. Gravity gathers matter into planets, stars, and galaxies. A human body, a tree, the sun, and the earth all exist because these forces operate together. Each force does what the others cannot. Gravity's special property is its long-range attraction between masses. This makes gravity the force of large-scale motion. It gives objects weight. It pulls falling bodies toward Earth. It keeps satellites in orbit. A satellite stays in orbit not because gravity disappears. It stays in orbit because it is continuously falling around Earth. The same idea explains the Moon's orbit, and the motion of planets around the Sun. Orbiting is not escaping gravity. It is falling with the right sideways motion. Electromagnetism's special property is that it acts on electric charge. It can both attract and repel. This makes it incredibly rich in applications. It powers electrical circuits, motors, generators, wireless communication, light, and digital devices. It also holds electrons around nuclei. It allows atoms to bond into molecules. In this sense, electromagnetism is not only a force of technology. It is also a force of chemistry, biology, and daily life. Electromagnetism connects the world of atoms with the world of modern technology. The strong nuclear force has a very short range. But within that range, it is extremely powerful. This explains why atomic nuclei can store large amounts of energy. In nuclear fission, a heavy nucleus splits into smaller nuclei, and releases energy. In nuclear fusion, light nuclei combine to form heavier nuclei, and also release energy. The reason nuclear energy is so concentrated is that it involves changes in nuclear binding. It is not just a rearrangement of electrons in chemical bonds. Nuclear energy is powerful because it comes from the binding of the nucleus itself. The weak nuclear force's special property is transformation. It allows particles to change type. This makes beta decay possible. This may sound distant from everyday life. But it is central to nuclear physics, particle physics, and stellar processes. In the Sun, the weak interaction plays an important role in allowing certain nuclear reactions to proceed. Without the weak force, the Sun's energy-producing chain would not operate in the same way. The history of matter in the universe would be very different. The weak nuclear force helps make transformation possible, from radioactivity to the life of stars. The four fundamental forces give us a powerful map of nature. Gravity shapes the universe on the largest scales. Electromagnetism explains light, electricity, chemistry, and the structure of matter. The strong nuclear force binds nuclei, and makes atoms possible. The weak nuclear force enables transformations that are essential in radioactivity and stars. By studying these four forces, we begin to see the universe not as a collection of separate objects, but as a connected system governed by a small number of deep physical rules. The universe is wonderfully diverse, but its behavior is shaped by just four fundamental forces.